Your Claude agent forgets everything when the session ends. User preferences, project conventions, past mistakes, gone. Every new session starts the same interrogation all over again. You'll learn how to build a Claude agent that never forgets. We'll cover the architecture, the creation API, a security catch that trips most people up, and the version history powering production audit workflows. Every managed agent session starts with zero memory carried over. The agent has no record of last time. Not the user's name, not the preferences they spent 10 minutes setting up, not the bug it helped debug on Tuesday. That's the default, and for production agents, it's a serious gap. Think of it like hiring a brilliant assistant with total amnesia every morning. Shows up, does great work. Next day, complete stranger. Memory stores are the fix, and they work in a way you probably didn't expect. What memory stores actually are? According to Anthropic's docs, a memory store is a workspace-scoped collection of text documents optimized for Claude. Attach up to 8 per session. Each one mounts as a directory inside the container, so your agent's memory is literally a folder on a drive. Surprisingly, not magic. 3 layers. Your API workspace holds the store. The session mounts it at /mnt/memory inside the container. The agent reads and writes it with the same tools it uses everywhere else. Writes persist back to the store and stay available across every future session. Without memory, every session cold starts. The agent knows nothing. With memory, context persists. User preferences carry. Project conventions stick. The agent picks up exactly where it left off. But how you configure the attachment, that's where most people get tripped up. How to create and attach a memory store. 4 steps to persistent memory. First, create the store with a name and description. You get back a memstore ID. Second, seed it with reference material before any agent runs. Third, attach it in the session resources array when you create the session, not after. Fourth, the agent reads and writes it automatically. That's the whole setup. In Python, 3 calls. Create the store, get back the ID, seed a memory at any path with whatever content you want, then attach it in the session resources array. The description from step 1 goes directly into the agent's system prompt. It tells the agent what this store is for and when to use it. One thing I haven't shown yet, what happens when 2 sessions try to write the same memory at the same time? Here's the security trap. Memory stores attach as read-write by default. Anthropic's docs flag this explicitly. If your agent processes user input, fetches from the web, or calls external tools, a successful prompt injection could write malicious content into the store. Every future session reads that as trusted memory. Use read-only for any store the agent doesn't need to modify. The fix is clean. Separate stores by access level. Reference material, standards, conventions, lookup tables, read-only. Per user context the agent updates, read-write. 1 session holds up to 8 stores. Split by ownership, not by data type. Simple in theory. Not simple when developers forget this exists entirely and wonder why their agent keeps rewriting the same user preferences every run. Reading, writing, and version history. 5 memory operations. Create places a new file at any path. It doesn't overwrite. Retrieve fetches the full content by ID. Update changes content or renames the file and creates a new immutable version. Delete removes the memory. Redact scrubs content from a historical version while keeping the audit trail, useful for GDPR compliance and for when the agent helpfully stored your API key in a memory file, which happens. When to use read-only versus read-write. Reference material like schemas and conventions. Always read-only. Per user preferences and history the agent updates, read-write. Stores shared across many sessions. Read-only unless you have clear write ownership. Unsure? Start read-only. You can always loosen access later. Every mutation creates an immutable version, full audit trail. Anthropic retains versions for 30 days, but recent versions are always kept, regardless of age. To roll back, retrieve the version you want and write its content back. For concurrent writes, pass a content SHA-256 precondition. The update only applies if the hash matches what you read. No clobbering. That's the safety mechanism. Limits and what to build next. 3 limits from Anthropic's beta docs you should know before you build. 8 memory stores maximum per session. 100 kilobytes, about 25,000 tokens, per individual memory file. And 30 days for version retention. The docs recommend structuring memory as many small, focused files, not a few large ones. My recommendation? Don't try to store your entire codebase in a single memory file. Anthropic agrees. Here's what we covered. Memory stores mount as directories at /mnt/memory. Agents access them with file tools. No special API required. Attach as read-only, unless the agent specifically needs to write. Every mutation creates an immutable version with a 30-day audit trail. Limits, 8 stores per session, 100 kilobytes each. And the description you write when creating a store goes directly into the agent's system prompt. Persistent memory is the missing piece for any Claude agent that needs to know who it's talking to. Next week, I'm covering the full managed agent session architecture, environments, tools, and how everything wires together. Subscribe, and it'll land in your feed. The official docs link is in the description if you want to start building now.